Hi, I'm Todd Bridigum, welding instructor at Minneapolis Community and Technical College. And we're going to be talking about gas metal arc welding aluminum. But first I want to talk a little bit about wire feed processes in general, so we have a broader understanding of what we're looking at. Wire feed is a general description of a lot of different welding processes. And here I have the wire feed family tree. At one end we have gas metal arc welding, which is generally using solid wires with a shielding gas as a supplement. Over here we have flux core arc welding, which is the use of a tubular wire with a flux core, sometimes needing shielding gas additionally, and sometimes the flux in the wire itself works on its own. And lastly, we have submerged arc welding, which is a little bit different than all the rest in that a granular flux is poured over the top of the weld as it is being made. We're going to be focusing on the gas metal arc welding category, and next we'll take a look at the gas metal arc welding process variable chart. So in our wire feed family tree we had the gas metal arc welding category, and there's, as you can see, a lot of variables within that category. This chart shows GMAW process variables for common industry practices. Over here we have our metals, whether we're welding steel, high strength alloy steels, stainless steels, or aluminum. Here we have the aluminum category, which is what we'll be doing today. The next column has the different modes of transfer: short circuit, spray, and pulse spray. We'll be focused on the spray transfer method. We'll be welding 1/8 inch and 3/8, and we'll be using the 4043 as our electrode today. Our load voltage for spray, anywhere between 21 and 30 load volts. And we are going to be using a straight argon shielding gas, although an argon helium blend can be used. We'll have our gas flow at around 40 to 50 cubic feet per hour. One thing that's unique about the spray transfer process with aluminum is that's an all position process. So we can weld vertical up and overhead with spray transfer, but only with aluminum, typically not done with steel. Our contact tip stick out is going to be anywhere from 3/8 to 1/2 inch. We're going to be using 100% argon as our shielding gas today, and we need to make sure that we have our flow meter set to the proper flow rate in cubic feet per hour. First we'll open the cylinder valve, and again, it's always a good idea in practice to stand to the side of the flow meter whenever you open the cylinder valve. You want to crack it open first and then open it all the way. We're going to purge the gas by hitting the trigger on the gun, and we're going to adjust our flow rate accordingly. Now there are different scales on this flow meter, and so we need to make sure that we're reading the right scale on it. We're reading the scale for argon, and we're at 40 cubic feet per hour. A lot of times with wire feed processes in GMAW, you may be using your wire feed machine for a variety of metals like steel, stainless steel, or aluminum. Just keep in mind you're going to need a separate shielding gas for each one of those types of materials. So if you have a cylinder of C25 and you want to weld aluminum, things aren't going to go very well for you. So keep in mind you want to make sure you have the proper gas for the type of metal that you're welding. With gas metal arc welding of aluminum, one of the challenges is feeding the wire and preventing bird's nests. Aluminum wires are softer, and they tend to kink up and bind up in a regular push type feeder system. So there's several ways to get around that. One is to use a push-pull type system, and another common solution is to use this, a spool gun, which is an accessory that's available for purchase with the wire feed machine you see here. So this spool gun takes 1 pound spools of aluminum, and the aluminum spool is held in this compartment right here. So we can see we've installed our 1 pound spool, and the wire's going through the inlet guide of the gun. If we flip this up, we can see the drive rolls here and here, which feed the wire through the inlet guide to the end of the gun. And our tension adjustment for the drive rolls is right here. When we flip that open, we can get a pretty good shot of taking a look in here at the drive rolls and the wire going through the inlet and outlet guides. One thing I always do before I start any wire feed welding is to check the gun, and especially the business end of the gun, the end. So first thing I do is I take the nozzle off, and I want to check it for any spatter or contaminants and make sure it's clean. The next thing I check is the contact tip. Make sure that it's in good condition and that it's tight. A loose contact tip can cause an erratic arc. With this spool gun, the wire feed control is actually in the handle of the spool gun itself. And as I control the wire feed speed and turn it up, you can see that the wire feed readout on the panel, the front panel of the machine, is changing and is reading out wire feed speed in inches per minute. A special consideration when welding with aluminum wires is their rate of expansion. Aluminum wires tend to get really hot in the GMAW process, and they'll expand. Many times, if you use a contact tip that's the same diameter of the wire, that will actually lead to bird's nesting. So I use a contact tip that's one large size larger than the diameter of the wire we're using. For instance, we're using an 030 diameter wire, so I have an 035 contact tip installed on this spool gun. Next, we're going to dial in the machine. We already talked about wire feed speed being adjusted on the spool gun itself, so we're going to set our wire feed speed at around 350 inches per minute. We have 20 volts showing on the panel of the machine, and that probably get us into a spray transfer. But what we're going to do as an experiment is turn the voltage down. And then as I weld, we'll increase voltage to show how we go from a short circuit transfer into a spray transfer mode. So at the beginning of this weld, we were in the short-circuiting transfer mode. As you can tell, the bead is fairly convex, and we had a lot of spatter coming out of the weld pool. As we increased the volts, we got into a nice spray transfer mode, and the spatter disappeared. And then as volts continued to increase, we started to see the puddle getting a little bit on the hot side for 1/8" material. One of the advantages to gas metal arc welding aluminum is we're using direct current electrode positive or reverse polarity, which gives us a cleaning action on the aluminum. And as you can see here, next to the weld bead, we see that cleaning action busting up the oxide layer on the aluminum itself, allowing us to make the weld. After we have our machine dialed in, we're going to make a fillet weld on this lap joint in the horizontal position. One thing with aluminum gas metal arc welding is you need to move along pretty quick. The weld will happen, especially with a spray transfer on 1/8" in a very short amount of time. So we have to pick up our travel speed and go just fast enough to make the weld happen down the joint. We're now going to continue making this weld bead on this horizontal lap joint, and we're going to perform a restart. Now, with gas metal arc welding, you always want to restart ahead of the puddle or where you ended, and then come back and tie it in. The reason why is if we restart directly over where we ended, the wire's cold and we won't necessarily get proper fusion there. So we'll restart ahead. And it's a very quick motion to come back to the puddle and then continue the weld. When we get to the end of the weld, we're going to pause for 1 second, allowing the crater to fill, but also allowing the shielding gas to protect the weld pool just for a quick second before we pull out. With wire feed welding aluminum, we can have problems at the start of the weld with a cold weld. So oftentimes people will start ahead of where they are going to begin the weld, pull the trigger, come back, and then again make the weld very similar to what we did with restarting. Another way to avoid this is to tack runoff tabs on each end of the joint you're welding. The beginning tab allows you to get the puddle nice and hot to start. You make the weld across the joint, and then the ending tab allows you to, if you have any craters, to crater out on that tab, and not a big deal. Modern power sources, pulse spray in particular, have controls that will adjust the current for a hot start and for crater fill. But with this power source, we don't have those controls, and so we're going to use the tabs instead. So again, we're going to start the weld on this first runoff tab, and then weld across the joint and end the weld on the other side. So we can see with the finished weld, we have a very cold start here on the runoff tab. And then once we get to the joint, we've got our heat and our penetration going. And we're pretty much good all the way down to the end of the joint. And then as you can see, I skipped over to this plate. And you can see actually where I cratered out at the end of the weld. Again, these are both on the runoff tabs. And so these runoff tabs can be broken off. And any of the tacks sanded down. Next, we're going to weld some 3/8 inch thick aluminum, and that's quite a bit thicker than the 1/8 inch we've been running. So we really got to crank up the settings. We're running at about 725 inches per minute on the wire feed speed and about 25 volts. We're going to put a fillet weld in this lap joint, and what you're going to see is a lot of wire whip with this. The wire is going to move around quite a bit coming out of the end of the gun, and that's because we're running a 1-pound spool. The wire is wound pretty tight around that, so as it comes out of the end of the gun, the wire still has that curve in it, and it'll tend to wiggle around. That's just something you got to manage as you go down the joint and make the weld. We've made a single pass weld in this fillet in this horizontal joint, but we actually want to make a fillet weld that's a little bit larger. So instead of using really slow travel speeds and a weave technique, we're going to run multiple passes. Next, we're going to make a second pass. The second pass is going to be between the first pass and this base plate right here. I'm going to angle the gun up a little bit more so I can get penetration into that base plate. But I'm going to run the wire right along the toe of the weld where the filler metal meets the base metal. Okay, I've made my second pass in the joint here. Again, by pointing the wire at the toe of the weld, and about half of the second pass is up on that first pass, and half of the second pass is down onto the base plate. Now I'm going to angle my gun slightly and make a third pass, tying in the second pass to the top plate. So now I've added my third pass and I've tied my second pass into my top plate. I don't have a lot of buildup at this top plate. It's a nice smooth transition from here down through the fillet weld and onto the base plate. So I've used a 3-pass welding technique to make a 3/8 inch fillet weld in 3/8 inch material. GMAW welding with aluminum is an all-position process, so we're going to make a fillet weld on this T-joint, and we're going to travel vertical up. We're also going to use a push technique, which means that we're going to point the gun in the direction we're traveling, and we use a push technique for all of the welds we make with GMAW on aluminum. Whether it's TIG, Wirefeed, stick, or oxyacetylene, I've written a lot of my thoughts in this book, How to Weld. It's available at Amazon.com and Barnes & Noble, along with other retailers. And I think it's a good reference covering much of the material that we've talked about in these videos and more.